Hello, my name is Shri and I'm an 8th grader. As part of my 8th grade science series, today we're going to be talking about non contact forces and signals. So, there are three main types of non contact forces, which are gravity, magnetism, and electricity. Gravity is a force that pulls downward toward the core of the Earth. Magnetism occurs because of the movement of electrically charged particles. Fundamentally, it is the push or pull between a magnet and a magnetic object. Let's focus on this magnetism for a moment. So, a magnet has two poles, the North Pole and the South Pole. Remember, a magnet is strongest at its poles. A magnetic field is the area around a magnet where magnetic forces can be detected. It flows from north to south, produced by moving electrical charges and can exert forces on other magnets. The magnetic force is the push or pull that a magnet exerts on certain materials. The pull force, or the pull between two magnets, is called attraction, while the push force, the push between two magnets, is called repulsion. The space between two objects, two magnets, can affect the intensity of a magnet's ability to attract or repel. In short, distance affects the effectiveness of magnetic interaction. Magnetic strength decreases with distance. So that's the magnet overview. So the Earth is a magnet. So then, how does a compass work? The geographic poles of the Earth refer to the northernmost point and the southernmost point on the planet, namely the North and South poles, respectively. However, the magnetic poles of the Earth are at the opposite ends. The magnetic South Pole is near the geographic North Pole, while the magnetic North Pole is near the geographic South Pole. The compass is attracted to the magnetic South Pole, so it points towards the geographic North Pole, though not exactly. So now that we've gone over magnets, what is an electromagnet? An electromagnet is a magnet that starts with electricity. An example is an iron nail coiled with copper wire with ends of the wire connected to a battery. The electricity from the battery charges the nail, allowing it to act like an electromagnet. Simple inventions such as doorbells use electromagnets to work. When connected to a battery, the electricity travels into the copper wires in the doorbell, charging them and changing them into electromagnets. Those electromagnets pull a metal rod toward it that hits the bell when moved. So when the so-called iron arm collides with the bell, there's a deformation that causes vibration and in turn sound, as we discussed in the sound waves video. If you have not watched that video yet, make sure to check it out. The link is in the description. So an electromagnetic buzzer also works in a similar way to the doorbell. Also, don't forget to like, share, and subscribe. So now let's talk about the third non-contact force, electricity. Electricity is the force between charged particles in an electric field. In an electromagnet, when the coil is connected to the battery, the electrons, negatively charged ions, start to move from the negative to the positive ends of the battery. This movement of charged particles is what is called an electric current. So the electrons do not actually move very quickly through the wire. They actually kind of drift slowly, but when the battery and the light bulb are connected, the electrons move randomly in zigzag patterns. But that's why, because the electrons start moving at the same time, energy is transferred immediately in the circuit. So an electric so, an electric motor is a machine that starts with electrical energy that is changed into mechanical energy, while generators transform motion into electricity. So, they convert mechanical energy into electrical energy. An example of a generator is a wind turbine, which generates power from movement. So now that we've discussed the important details of non-contact forces, let's go over signals. There are two main types of signals, analog and digital. Analog signals are continuous, like an analog clock, whose hands keep moving continuously. A digital signal, on the other hand, is different. It's like a digital clock. You see one thing for a minute, and then it suddenly changes to the next minute instead of moving smoothly. It uses a binary code, usually in digital signals, of ones and zeros and is much easier to decipher in case of transmission interference. So yeah, that concludes our video about non-contact forces and signals. Thank you for watching.